Assalamualaikum and hi. Today you are going to learn about the chapter 5 state of matter 5.4 phase diagram. What we are going to learn from the 5.4 phase diagram, you are going to define phase, triple point, critical point, identify triple point and critical point on the phase diagram, sketch phase diagram, compare phase diagram water with the carbon dioxide and explain anomalous behavior of the water, and E, describe the changes in phase. According to the Riemann-Choek 8 editions, phase is defined as a homogeneous part of a system in contact with other parts of the system but separate from them well-defined boundary. Homogeneous part consists three. One is a solid, second is a liquid, third is a gas. We have some example here. So look at that picture. We have a mixture of the water and ice. Can you think how many phases exist there? Correct, there are two phases here. What is that phase? Yeah, it's a solid phase and the liquid phase. What about this example? Which is we have a table of solutions. So correct, is a one phase, which is a liquid phase. What about this one? So we have a mixture of water and oil. Yes, two phases. What is that phase? Is a liquid phase. Why we can say that two phases? Because we can see the boundary between the water and oil. So here we can conclude for different systems, we can see that the mixture of the gases, so is only one phase because we cannot see the boundary between the gases. Let's say we have two liquids do not mix together. So is a two phases exist because we can see the boundary between the two liquids, and we have the system with the two liquids well mixed, so is only one phase, which is we cannot see the boundary of the solutions. So what is a phase diagram definitions? According to the Bronsted 14 editions, phase diagram are graphic representations of the equilibrium among the solid, liquid and gaseous phases of a substance as a function of temperature and the pressure. So we are going to focus for two substances. One is for carbon dioxide, the second one is for the water. So look at these phase diagrams. So what you are going to have on the phase diagram, first one you have to know the y-axis is pressure, second axis is temperature, and each phase diagram must have the solid, liquid and the gas phases. Then you can see the line AB, line AD and the line AC. So line AB is represent the solid and the gas at equilibrium. So for the line AD is show that solid and liquid in equilibrium. For the line AC is for the liquid and gas at equilibrium. So from this phase diagram, you also can see the point A, so and also the point C. A we call as a triple point, C is a critical point. So what is the definition for the triple point? According to the Brown 14 edition, triple point is defined as the temperature at which solid, liquid and gas phases coexist in equilibrium. So what about the critical point? So according to the Brown 14 editions, critical point defined as the temperature and the pressure beyond which the liquid and gas phases are indistinguishable from each other. Here we can see that the end of liquid gas line, density of liquid equal to density of gas. At this point, which is a critical point, the average kinetic energy of the molecule is so high that the gas cannot be condensed no matter how much pressure is applied. Phase boundaries disappears, separate liquid and gas phase no longer exist. So let's say we are focused on the phase diagram of the carbon dioxide. You can see the phase diagram on your right side. You can see the pressure. You can see the pressure here. We can see the temperature. Then you can see the solid, liquid, vapor. And you can see a few label here, 5.2 atm at the negative 57 degrees Celsius, 1 atm at the negative 78 degrees Celsius. So you also can see the label of the AO, OB and the OC here. Okay, so from this phase diagram, we can see that the carbon dioxide is a gas under normal conditions. What is the meaning of the normal conditions? So meaning at the 1 atm. So look at the line AO. Line AO we call as the sublimation curve or deposition curve. It shows that the carbon dioxide solid equilibrium with the carbon dioxide gas. Another line is line OB, which shows the melting curve or freezing curve. Carbon dioxide solid equilibrium with the carbon dioxide liquid. Another line is the line OC. It shows that carbon dioxide liquid equilibrium with the carbon dioxide gas. So we can see here the point O, which is called as a triple point for the carbon dioxide, with the value negative 57 degrees Celsius at the 5.2 atm. So we also can see that the solid, liquid and vapor at equilibriums at the point O. So another point that you can see here is a point C, we call as a critical point. So we cannot see the value, but actually the critical point for the carbon dioxide is at 31 degrees Celsius at the 7.3 atm. We still use the phase diagram for the carbon dioxide as example, but now we set the constant pressure, what we call as the isobaric. Okay, can you see the 5.2 atm pressure? So we set the pressure constant below 5.2 atm, but what we increase here is the temperature. Look at that red line here. Can we describe the phase changes along that red line? Yes, okay. So phase change from the solid gas in equilibriums, then to the vapor, or it can happen vice versa. So let's say we heated the carbon dioxide at the 1 atm. You can see from the green line there, what happened? You can see the carbon dioxide sublimes at the negative 78 degrees Celsius. Look at this phase diagram, it's still carbon dioxide. Now we set the constant pressure above 5.2 atm. Can you see the red line there? Can we describe the phase changes? Yes, so the phase changes is from the solid, liquid in equilibriums, liquid here, liquid, vapor in equilibrium, then vapor or gas, or it can happen vice versa. So this is happen at the constant pressure or isobaric. We still use the phase diagram as example, but now we set at the constant temperature, or the term we can use is isothermal. So let's say we have the red line here, which is we set the temperature is a constant below negative 57 degrees Celsius, but we can increase or decrease the pressure. So can we describe the phase changes if we increase the pressure? Yes, okay. The phase change from the gas, solid in equilibriums, then to the solid or vice versa. Let's say we have the carbon dioxide phase diagram, but now we set the constant temperature. You see the red line there? So we set the temperature constant is above negative 57 degrees Celsius. Can we describe the phase changes? So the phase change from the gas, liquid in equilibrium, liquid, solid in equilibrium, then to the solid or vice versa. So one thing that you have to remind that the phase diagram of the carbon dioxide is typical for the most substance, which is the solid liquid line is a positive slope, meaning it's slant to the right. So it means melting point increase when the pressure increase. So what is the meaning of the positive slopes? It means that melting point increase when the pressure increase. So why? Because the solid carbon dioxide is more dense than the liquid carbon dioxide. So at high pressure, it favors the formation of solid carbon dioxide, which has a smaller volume. Therefore, more heat is needed to melt the solid carbon dioxide. So means solid carbon dioxide melts at higher temperature at high pressure. This is a phase diagram for the water. You can see from your left side, water is a liquid under normal conditions. So it's the meaning of normal conditions at the pressure 1 atm with the temperature 25 degrees Celsius. So at 1 atm also we can describe the phase changes, meaning water exists at the solid, then solid liquid in equilibrium, liquid and gas in equilibrium, or vice versa. At 1 atm also we can see the water melt. Okay, water melt at the 0 degrees Celsius and water boil at the 100 degrees Celsius. There are 2 points we can see here, which is a point O and point C. Point O is a triple point at the 0.01 degrees Celsius with a pressure 0.006 atm, while the point C is a critical point at a 374 degrees Celsius with a pressure 218 atm. Have a look at the phase diagram for the water. You can see the solid liquid line slopes to the left, which is a negative slope. What does it mean? It means that the melting point decreases when the pressure increases. What does the negative slope means? So it shows the anomalous behavior of the water, means melting point decrease when the pressure increase. So why? Because the solid of the water, which is ice, is less denser than the liquid water. At high pressure is favor the formations of liquid water, which has a smaller volume. Therefore, less heat is needed to melt the solid water. So water melts at lower temperature at high pressure. Okay, before class ends, let us try to do these examples. Explain the phase changes of substance X, A from point A to B, B from point B to C. I give you 2 minutes to try to do these questions. You have the answer now for the equations. So you can see at the point A, X exists as gas. When X is pressurized isothermally, X start deposited and gas solid coexist in equilibrium. Continue pressurized, X will be entirely in solid phase at the point B. For the second question, which is from point B to C, you can see here. So at the point B, X exists as solid. When X is heated isobarically, X start to melt and coexist as a solid liquid in equilibrium. Continue heating until point C, X exists as a liquid phase. So that's all for today. If you have any problems, please come to see us at the chemistry unit. Thank you.